We are now on Unit 1/2.7. Today is the last lecture for this unit. Okay. Your homework says that there is an A and a B portion. We are only going to do one lecture, and really you just have an assignment that has two parts. Tonight you are going to have some stuff from the book and some things from a worksheet. Okay, so we are working on solving systems of linear equations, solving systems of linear equations. And we've done that before. Remember, a system of linear equations is just more than one equation. Okay, so more than one line. We're figuring out where they cross. But we're going to change today, and we're going to step it up a little bit, and they are going to be in 3 variables. So instead of just having x's and y's, we're going to introduce another variable as well today. Okay, all of your instructions will say solve the system. Okay, for number 1, I'm going to give you the systems of equations. 6x plus 2y plus 3z equals 35. The equation 3x minus 5y equals 19. And the equation 4y equals -8. The first thing we want to do is I want you to label your equations. So just write equation 1, equation 2, and equation 3. There's so many equations that just it helps to label them. Okay, so automatically, do you see something that you can solve? Yes, I hope so. Okay, hopefully you can see that in equation 3, we could already solve for y. Okay, that's a good thing. Let's go ahead and solve equation 3. So 4y equals -8. If you divide both sides by 4, we will get y equals -2. So we've already found one of our variables. Already found the answer for one of our variables. Now we can take what we found and we can use the other equations to solve for the other variables. So now I'm going to use equation 2. And I'm going to plug into equation 2. Equation 2 was 3x minus 5y equals 19. But now I have a value for y. So I'm going to plug in. Remember, whenever you plug in, you do need to put something in parentheses. So times -2 equals 19. You're going to multiply through. Those negatives will cancel. So 3x plus 10 equals 19. Then subtract 10 from both sides. Use the additive inverse. Leaves us with 3x equals 9. Then divide both sides by 3, and you should get x equals 3. Okay, now I have 2 parts of my answer. Okay, now I can use equation 1. Use equation 1 and use both of these parts to solve for the last remaining variable. So 6x plus 2y plus 3z equals 35. I know the y and I know the x. So 6 times your x is 3 plus 2 times y of -2 plus 3z. I always put those little lines in the middle of my z's so they don't look like 2's. Okay. Then go ahead and multiply through. So 9, sorry. 6 times 3 is 18. Sorry, adding. 18 minus 4 plus 3z equals 35. Combine like terms, so 14 plus 3z equals 35. Move numbers and letters to opposite sides, so move the 14. Subtract 14 from both sides. And that's going to leave us with 3z equals 21. Divide both sides by 3, and we will get an answer of z equals 7. Now, the answers for these problems. Answers need to be written as what's called an ordered triplet. Okay, so answer as ordered triplet. Okay, we usually put our answers as an ordered pair because there's two things. Pair means two. An ordered triplet, you're going to write it X, Y, Z ordered triplet. So we're just going to fill in. So your X value here is 3, the Y is -2, and Z is 7. That's the answer we're looking for. 3, -2, 7 is the answer to the systems of equations. You see how I got the -2? Right up here, I used the first one and I solved for Y. Make sense? Okay, let's try another one. So we're going to be using 3 variables today, X, Y, and Z. Okay, let's try another one. For number 2, I'm going to give you the systems of equations. 4x plus 2y plus 3z equals 1. 2x minus 3y plus 5z equals -14. And 6x minus y plus 4z equals -1. So this is a little bit more complicated than the last one, okay? We're still going to start the same way. So I want you to label them equation 1, equation 2, equation 3. Now, when we solve systems of equations, we typically use either the addition method or the substitution method. So I'm going to show you how to solve this with both of those methods. Okay, the first one we're going to do is the addition method. Okay, so using the addition method, step 1 in the addition method is I want you to pick a letter to eliminate. Pick a letter to eliminate. Okay, so if you look at these, which letter do you think would be easiest to eliminate? Remember, we're always going to be multiplying by something and then adding them together to eliminate it. Probably the Y, because, well, it's a small number, it's by itself, so it would be easy to multiply. So we're going to write ourselves a little note, okay? I'm going to eliminate the Y. So just kind of write yourself a little note, okay? Step 2 is you need to pick 2 equations. Pick 2 equations to eliminate the letter from. Okay, pick 2 equations to eliminate the letter from. We already decided we're going to eliminate Y. Which 2 equations would I like to eliminate it from? So you want to do 1, 2, and 3? Which ones? Pick 2. You want to start with 1 and 3? Okay, and I'm going to write like kind of a little post-it note to myself here. Okay, so we're going to start with equation 1 and equation 3. So just rewrite equations 1 and 3 here. So 4x plus 2y plus 3z equals 1. And equation 3 is 6x minus y plus 4z equals -1. Now, if I want to eliminate y, I need to multiply through to eliminate these y's. So I have a positive 2y and a -1. So what would I have to multiply by to get rid of the y? A positive 2, okay, because then I'm going to have a positive 2 and a -2. We're going to rewrite this. So 4x plus 2y plus 3z equals 1. That's just your first equation. Nothing's going to change there. The second one, I'm going to distribute through a 2. So 12x minus 2y plus 8z equals -2. And then I'm going to use the addition method. The y's will cancel and just add everything else together. So 16x plus 11z equals -1. And just kind of hold that equation on the side. Step 3 is you want to pick 2 different equations. So pick 2 different equations to eliminate the same letter from. So pick 2 different equations to eliminate the same letter from. So we're still going to be eliminating y. So write myself a little note. And instead of using 1 and 3, which ones do I want to use? 1 and 2 or 2 and 3? Does not matter at all. Okay. Do you want to use 1 and 2 or 2 and 3? 2 and 3. Okay. Equation 2 and equation 3. It would work if you use the other as well. Okay, so equation 2, we had 2x minus 3y plus 5z equals negative 14. Equation 3 is 6x minus y plus 4z equals negative 1. Okay, so I want to eliminate the y again. I already have a negative 3y, and I have a negative y. So I could multiply the second equation by a negative 3, and then you'll have a positive, 1 positive 3, 1 negative 3, and they'll be able to cancel out. So just rewrite the first equation. So I'm going to line them up and distribute through a negative 3. So negative 18x plus 3y minus 12z equals positive 3. Add them together so the y's will cancel out. 2x minus 18x gives you negative 16x. Combine these together, minus 7z equals negative 11. So now I've created another equation here. The next step, step 4, is to use the new equations. So use the new equations I made that do not have the y in them. So use the new equations and solve the system. Okay, so take those two new equations. So I had 16x plus 11z equals negative 1, and negative 16x minus 7z equals negative 11. Now, if you notice, these are set up really nicely so that if you use addition method, the x's already cancel out, which is what we want. Okay, so 11z minus 7z gives you 4z equals negative 12, and then you can solve. Divide by 4. And that gives you z equals negative 3. So I have one of my variables. Now, the last step, step 5, is to plug in to find the other variables. Okay, these are long questions, I know. Okay, but it's it's what you already know. We're just adding to it. Okay, so we're going to take z equals negative 3. Now, obviously, I don't want to plug into one of these equations up here because they're long. There's too many unknowns here. You want to use one of the equations that you created. Okay, that will help you. So it does not matter which one you use. I'm probably going to use the positive one because it has positive numbers instead of negatives. So 16x plus 11 times negative 3 equals negative 1. 16x minus 33 equals negative 1. Oops, excuse me. Add 33 to both sides. Sorry, I'm throwing things at you guys. Add 33 to both sides. That gives you 16x equals 32. Thank you. Divide both sides by 16. And we get x equals 2. So we're getting closer. Now I'm going to take those two variables and plug in to find the last one. So you are going to have to use one of these big equations at the top. Okay? Doesn't matter which one. I'm going to use the first one because it seems a little bit easier. So plug in what you know the x, so 4 times 2 plus 2y plus 3 times we know the z equals 1. 8 plus 2y minus 9 equals 1. Negative 1 plus 2y equals 1. Add 1 to both sides. It's going to leave us with 2y equals 2. Divide both sides by 2. And we get a y value of 1. So, write your answer here as an ordered triplet. It would be 2, 1, negative 3.